Hey guys, in this tutorial we're going to be learning how to use capsule collision instead of just normal box collision. We're going to create our own little capsule class, and as you can see on the player here, he is using it. It's got two circles and a square. Now that he has rounded corners, the shape more closely matches his body, and it also allows you to walk up little ledges, whereas normally you would get stuck on those ledges since you had hard corners. So yeah, stay tuned for the tutorial. So we want to make a capsule collision shape. Now let me first show you what that is. Right now what we're doing is we're just using regular bounding box collision. So this is what we have. We just have a box. And when we collide with things, say we want to step up on a ledge, something like that. Say we have just a tiny little ledge right here. If we were to try to go to the right and actually try to step up on that ledge, what we're going to do is we're going to hit this ledge and we're just going to stop since we're a box. However, if we had a better collision scheme using capsule collision, which will look something like this, let's say about that big, and then we have two circles like this, about like that. So this is a capsule collision box, and what's great about this is if we move to the left here and we run into this little red ledge, since there's actually a sloped surface here, when we actually hit it, as long as we're going with enough force, we'll step up onto it. Not to mention, this better approximates a human body. Like, you'll have the head up here at the top and you'll have the feet up here at the bottom. With the regular box collision, we've got these corners here that really, for most sprites, you're not going to want to have all this extra corner stuff because it's going to be causing you to collide with objects really far away from where your feet or your head are. So let's go ahead and jump right into implementing this. It's actually a fairly simple thing to do. What we need to do is we need to go ahead and create another class, and it's going to be a capsule class. So let's go into our Ninja platformer and we're going to do add class, and we'll call it capsule. Sort of like how we made the box. Alright, there we go, capsule. Now let's go ahead and do a void init function, and let's put some private variables. And you know what, we don't need a constructor or a destructor here. We're not going to be really doing anything with them. No need to have them. Now what we can do here is we can copy a lot of the stuff from the box because it's going to be really similar. This is box.h. We do need a body. We need a fixture. We actually need three fixtures, one for the central box and two for the two circles. We're going to need dimensions. We're actually not going to do color or texture. This capsule is not going to be doing any rendering. We're going to do rendering separately. So I'm just going to copy these. And now instead of mFixture, it's going to be mFixtures, and there's going to be three of them. And we also need to do some includes, so let's just steal all the includes that we need from the box.h, and I believe just those two. So let's grab those and put them up here. There we go, and we can't do equals null pointer in the header when you have an array, unfortunately. We'd have to do that in the constructor if we had one, but really it doesn't matter. Now the init function is what's going to actually set up our capsule, and it's actually, again, going to be really similar to the init for the box.h. So let's just grab this. We do need position, we do need dimensions, we do need fixed rotation, but we don't need texture, color, or UV rect. So we're going to copy this and then strip those out. So texture and color, nope, don't need you. UV rect, don't need you. So it's even simpler. Now let's go ahead and grab this and put it in the CPP file and create our little implementation here. So this will be capsule ::init. Now again, it's going to be really similar to the box initialization, so we can go into the init. This first part right here, where we set up the body definition, it's going to be exactly the same, so we can definitely copy that. And then the box creation is going to be almost exactly the same as well. So let's just grab all of this. Let's see, we're going to want this whole thing here, and we're going to put that in capsule. And now we're just going to modify it to our needs. So we don't need color, texture, or UV, that's why those are red. And now here, instead of mFixture equals body create fixture, we're going to say mFixture 0. That will be the first fixture. Alright, let's see. mFixtures. So now we have our capsule init function, but right now it's only setting up just the first fixture, which is the main rectangle that we normally use. So what we're going to need to do is also add two circles to this. But to make sure we're doing everything right so we can do some incremental testing, let's just start here and just pretty much use the capsule in place of box and see what we can get on the screen. Now what I want to do is I want to add a draw method here. Now typically it's a bad idea to add draw methods to classes like this. Really it should be a separate layer like you learned in the ball game, but I'm just going to do it here because we're not really concerned about the finer points of software architecture, since you guys already know that. We can just be kind of sloppy here for this quick game. So we're going to say draw debug. And what's it going to take? It's going to take a Benjin debug renderer, and let's include that up here. And what is it? Debug. Will it autocomplete? No, it will not. Debug render.h. And that should work. There we go. Now we have draw debug. Let's implement that, and that'll allow us to actually draw the fixtures. And let's do capsule : : Now for this we can steal a little bit more code. We're going to go to main.cpp. Whoops, no, not main.cpp. We're going to go to the gameplay screen.cpp. And down where we are drawing all this debug stuff, like I'll grab it from where we have the player here. We'll just take this whole thing because it's going to be the same for drawing the box of the capsule. Now instead of b.getBody, we can just say mBody, since we actually have the body inside this capsule. We can do that, b.getBody, replace that. Instead of b.getDimensions, we can just say mDimensions, because we have that as well. So we'll grab that, and this, and the destination rectangle is a glm vec3 dest_rect. Here we go. And let's see, it's actually a vec4, not a vec3. And now it should allow us to draw it. Here we go, it's another body, so b.getBody should be mBody, getAngle. And let's see, what else are we getting? mDebug render needs to be just debug render. There we go, now we can draw debug. So what we're going to do is we're going to take this and also put it in the player. So let's go to player.h. We're going to make a draw debug function. Void draw, oops, let's put that right under draw. Void draw debug. And that'll pass in the debug render, and we're just going to pass this through to the capsule. So because we're doing that, we're going to replace this box with a capsule. So let's go ahead and include the capsule. Include capsule, and I'm going to go ahead and get rid of box since we no longer are using box. So we're going to say capsule capsule. And we can return the capsule with getCapsule. Return mCapsule. There we go. And now let's go into the init, because things are going to have to change here. We're no longer calling mCollisionBox.init. We're going to call mCapsule.init. And we're going to pass in world, we're going to pass position, we're going to pass dimensions, and we're going to pass fixed rotation will be true for the player. And we're probably going to want to expand this to allow us to pass density and friction as well, because we haven't done that yet, and that's important. Now what are we going to do with texture, color, and UV? Well, we're going to actually just use these in player. We're going to store these. We need to render it with a separate layer. We're not going to render using the capsule or the box because we need to kind of change the dimensions of our rendered sprite in comparison to the actual box that we're drawing. Because as you can see here, each of these cells, really the player only takes up part of it for most of them. However, if we draw the player within the bounds of the collision box perfectly, there's going to be a bunch of wasted space. So we're going to have to kind of make the sprite a little bit bigger than the collision box, or the collision capsule. And where was I? Back to init. Back to not init. We need texture and we need color. We need to store those. And actually, we don't need to store color or UV rect. We can just hard code those into draw right now since we're bad programmers. Just kidding. Let's just store the texture. So we're going to say Benjin texture, or GL texture, and we'll say mTexture. And then we're just going to say in the init function, instead of this Benjin texture equals, we're just going to say mTexture equals. And then we can get rid of all this. I guess we should store the color since we're passing it in, just to be safe. So let's go back into player.h and store that. We'll say Benjin color RGBA8 mColor, and we'll set that equal to whatever they pass into that init function. And we're not using the constructor or the destructor in player either, so let's get rid of those and stop cluttering up our file with them. And mColor equals color. There we go. Now everything is set up here, and in draw we're not going to do anything with a collision box. Instead we're going to implement our own draw logic. So let's just steal it from draw like we always do, or steal it from box and put it in player because it's pretty much the same code. And here, instead of body arrow get position, we're going to be getting the position from the capsule. So we'll do that here in a second. Now, I forgot what the UVs were, and I don't want to think about it again, so I'm going to undo and steal that. There we go. And then redo. Little hacky trick. It's dangerous, but as long as you don't mess up, it works. There we go. And texture ID, that's correct. Color. Now here, for the body and the dimensions, we're going to be getting these from the capsule. And I think we can just go ahead and steal some more function definitions from box since they're the same. So we'll have get body, get fixture, get dimensions. We don't need get color. Let's just put those in capsule.h. Now instead of get fixture, it's going to be get fixtures, and it's going to return, or we can say get fixture with the index. That's even better. We'll say int index and return fixtures index. Now we'll return the fixture that they want. So there are 3 of them. They can enter a 0, 1, or a 2. Not that we're even going to use this, but it's there. Now we're going to go back to player.cpp, and now we can actually get the body. So we can say, we'll say, what is it, b2 body star body equals, it's going to be capsule get body. And I believe this returns a constant body. No, it does not. It just returns the body. Cool. So now we can replace body with body. And for dimensions, we can just say capsule.get dimensions .x and y. There we go. And for now, this is going to be wrong. We're going to be changing this later. Let's see, body get angle. Because we do, remember I said we need to actually make this a little bit bigger than the capsule, but we're just testing our capsule basic code for now. Here, instead of collision box get body, it's going to be capsule get body in the update function. That's all you have to do there. Same thing down here. It's going to be instead of collision box, it's going to be what is it? Body, or sorry, it's going to be capsule.get dimensions. All right, we should be good to go now. We're probably going to have a few errors because our call sites are different, so let's just see what all those are. B cannot be used before it's initialized because getBox no longer exists. Instead of doing all this crap, we can now just call the draw debug function. So player draw debug, and we'll pass in debug render. And let's see, that was a lot of them. And let's see, what is this? Left of .y. Let's just run it again and see how many more errors we get. All right, we have a linker error, draw debug, bingen debug render. Let's see, we have a linker error in player because I didn't pass it through. So we got to take this and put it in the CPP file and just pass that through. So we're going to call capsule draw debug with debug render. And now we can run it. And it should look exactly the same as it did before. We should just have the regular collision box, there it is. But now instead of using the box class, we are using the capsule class. So now we can make a whole bunch of modifications to this class and get a better collision method for our player. Alright, so let's go ahead and quit out of that and start messing with the capsule. So if we go into, what is it, capsule.cpp. Alright, so here we have just the creation of the body, and then here we have the box. So create the box. Now let's pull paint back up. Probably shouldn't have deleted it. So right now we have this, but what we want to do is we want to turn it into something else. So we'll start with this. Here's what we're modifying, the one on the right. First, we need to add the bottom circle. So what we're going to be doing is we're going to be creating a circle that has the radius that is equal to the half of the width of the box. So this right here, this is the radius, which is half the width of the box. And we're going to put a circle there on the bottom, just like that. And we're also going to be putting a circle on the top, just like that. Now we've still got these corners here. So what we're actually going to be doing is we're going to be shrinking the box so that it looks like this, so that it's in line with the centers of the circles, like that. So now we have that smaller box that is actually shrunk by 2 times the radius of the circle, which is also equal to its x dimension. So we're just going to subtract the x dimension from its height, basically. And then we have the circles and everything, and it's great. So hopefully you understand that, and we can get started with messing with the circle and shrinking the actual box. So let's start by just doing the circle. So create the circles. We'll say, yeah, we can actually reuse some code here. So we only need one circle shape. Now instead of B2 polygon shape here, oops, and I have this comment in the wrong spot. Instead of the B2 polygon shape, we're going to be using something else. We're going to use B2 circle shape. Now you could use polygon shape to make a circle, but you'd have to define the vertices yourself, and I imagine there's optimizations that come from using the B2 circle shape, so you should definitely use that. We'll call this circle shape. Now we need to do a few things. We need to set the radius, so let's say circle shape dot set or dot m radius equals, and for our radius, like I said, it's going to be equal, it's going to be equal to half of the x dimension. So let's do that. So m radius equals dimensions dot x divided by 2. Really simple. Now let's go ahead and create a fixture definition for this as well. We'll say b2 fixture def, and we'll call this circle def. And we're going to set some stuff for that. And let's make it look kind of like the box one, kind of have the same layout. Circle def dot, now we need to set the shape, and the shape is going to be equal to a pointer to circle shape. Then we're going to set, let's see, the density, and we're going to, circle def dot density, and this is going to be the same. We're just going to say 1.0f. This is something that we're going to probably need to change because I don't think 1.0f is going to work well as we change the size. And friction is going to be, we'll say 0.3, but we'll definitely want to change that as well. So now we have the shape, the density, and the friction. Now what we need to do is we need to actually set the position relative to the parent body, and then we need to hook it up with our actual body. So we're going to do the bottom circle first. And for the position of the bottom circle, the way we set that is we call circle def dot set, dot mp dot set. And this is going to set the position. And it's not going to be the position in the world, it's going to be the position relative to our parent body. So here we have this position, this body def dot position dot set. It's going to be relative to this. So if we set the position to 0, it's going to be centered right here at the body. So this position we're setting is the position of the center of the circle. So let's pull up our handy little image here. Now if we have the position set to 0, I'm going to draw another blue circle. We'll use the left box here. If we have position set to 0, this is where the circle is going to be. Now if we subtract from the y coordinate half of the dimensions in the y direction of the box, that'll put us down here. And then if we add half of the y dimensions of the circle, that'll put us right here, which is exactly what we want. So let's try doing that. We're going to say, and this should be at capital S, that's why it's giving me this error. So the x is 0, it's going to stay centered, but the y, we're going to say, we're going to take the negative of m dimensions dot y plus the dimensions of our circle, which is going to be this dimensions divided by 2. And actually we need to divide y by 2 as well, so we can actually just do this. We can say negative dimensions dot y plus dimensions dot x, whole thing divided by 2. That's the same as saying dimensions dot y divided by 2 plus dimensions dot x divided by 2. And that should set our body where it is supposed to be, and we're still getting an error. Circle def, this should be B2, this should be, this shouldn't be the fixture definition, this should be the shape. Circle shape dot mp dot set, that was the problem. And divided by 2.0f, there we go. So this is going to set the bottom circle. Now for the top circle, we're going to do basically the exact opposite. So top circle. And for this one, we're going to say positive dimensions dot y and negative x. We just flip that around. Now we have to actually add these, so we're going to say for this one m fixtures 1 equals m body create fixture, and we're going to pass in the circle def, and we'll do the same thing for the top circle. There we go. Now let's render these circles, so we can do that in our draw debug. So draw circles, whereas this is draw box. Now for actually drawing the circles, we just need to call our debug render .draw circle function that we created. So debug render.draw circle. But before we do that, let's actually shrink our box before we worry about rendering it, because we want to make sure we have the correct dimensions for everything. And right now our box shape is exactly the same as it was. We actually need to be shrinking it by the x dimensions. So when we say set as box here, we have dimensions.y divided by 2. All we have to do is say dimensions.y minus dimensions.x divided by 2. Because remember, this takes the half width, or the half height. And that's going to shrink our box like we wanted it to. Now for the position of the box, it can stay exactly the same. We don't have to worry about that. And I think this is pretty much good. So now we can actually draw our debug box knowing that it's in the correct place. So this stays the same, dimensions.x divided by 2. Yes, it stays the same x position, but the y position needs to change since we actually shrunk it a little bit. And we're going to be doing the same exact thing we did above. We're going to just subtract m dimensions.x. That will push it up. Since we're dividing by 2 here, it'll push it up by half of the dimensions.x. And for the desdirect.w, which is the y width, or the height, whatever you want to call it, height. I know people have got on me for saying height, it's height. And we just subtract m dimensions.x from that as well. And that's going to give us exactly what we want. Now that when we draw it, we should see the shrunken box. And now we can draw our circles. So for the position, we're going to say glm vec2, and it's going to be the destination rectangle dot x plus m dimensions dot x divided by 2. We're just going to be making sure we center it just like we do normally. And for the y position, we're going to be calling just the destrect dot y. Now for the color, we'll just pass in white. We'll say Benjin. Let's just use the same color. We'll say we'll put a color up here. Benjin, so we don't have to keep typing this. Color RGB8. Color, that's going to be 255, 55, 55, 55 for white. So let's just pass this. And really, we could probably pass a color into draw debug, so we're not hard coding it to be white. But I didn't do that. Sorry. Alright, color, and for the radius, remember what it is, it's m dimensions.x divided by 2. So that is one circle. Now we need to draw the other one. So for this one, so the desdirect.y, I believe this is going to be the bottom circle, and then the top circle is where we just take everything is exactly as it is, but we change the y position by adding desdirect.w. So that'll push us up by the length or the height of this box. So if you visualize it here, it says this, we've drawn the red box here. I'll draw it here. That's not a box. We've drawn the red box, and now we have drawn the bottom circle down here, and then what we want to do is draw another circle, so we're going to take everything we used to draw this and just push it up by the height of the red box, and then I'll put it up at the top. And I believe this is going to work, so let's go ahead and test it out and see what it does. And there we go, we have a little capsule. And as you can see, it seems to be colliding correctly. If I walk around here, he slides, and I can even go up little corners. Let's find a little corner. Here's a little corner. Looks like we have a little bit too much friction. It's not really letting me go up these steeper slopes very much. So let's go ahead and change that. Let's go back into the graphics tutorials, and let's change the way we set up our capsule. Let's also pass in two more things. Let's pass in a float density and a that's not a semicolon, float friction, so that we can change this for all of our different objects. So now instead of density equals 1, we're just going to say density equals density for all of these. And for friction, we're going to say friction equals friction. And of course, we're getting errors because this isn't in the header file like it should be, so let's put that there. And right here, density friction. There we go, now it's good. So in player, when we actually initialize this capsule, we have to pass in some more variables here. For the friction, let's try just 0.1f, which is 1/3 of what it was. And for the density, we'll keep it at, what was it, 10? Or was it 1? Was it 10 or 1? I don't know. We're gonna find out. All right, so I'm running it again. And let's see. Oh, I did something weird. Oops. There we go. And I'm trapped. Let's try again. Without getting trapped, preferably. Now, it looks like 10 was too much. I think it was actually 1. Y'all probably know that, so let's change it back to 1. And now we can run it, and hopefully jump really high in the air. There we go, and now we can jump, and 1 seems to be okay for jump height, I guess. And our friction is a lot less now. We're faster. We can climb up slopes much easier. And if we get stuck on a little edge, we can actually climb up on it if it's small enough, which these ledges are in fact not small enough. Let me see if I can find one that's small enough. There, I guess that counts. I don't know. But now you guys understand how to use capsule collision instead of the normal just bounding box collision. Let's go ahead and change it so that it properly is sized to our player, because right now it's a little bit too big for our player, which is what we were complaining about in the beginning. There we go. So what we need to do is when we actually initialize the player, we can have 2 sets of dimensions. We'll have a collision dimensions and a draw dimensions. So let's change this to collision dims and player collision dims. And we're going to add another one, const glm vec2 draw dims. And let's make a new line, or 2, because this is getting, or 3, because it's getting too long, and I don't like it when it gets too long. Or 4. I like the way that looks. Let's grab all of this and put it back down here. Now we have draw dims. So draw dims is actually something we're going to want to store here when we go to render our player. So we're going to do glm vec2 im dim draw dims. And we'll set that just as easily. Im draw dims equals draw dims. And now when we actually draw the player, we're going to be using draw dims instead of capsule get dimensions. So we'll say draw dims x, draw dims y. And I believe for the y, we actually want to keep the capsule y offset, or was it the, was it the x? No, these sizes definitely have to be draw dims. However, for the y dimension here, instead of using the draw dimensions, we want to make sure that when we push the player sprite down, his feet are lined up perfectly with the bottom of the collision box, whereas everything else can overlap. So here we're actually going to definitely be using the capsule. So im capsule get dimensions dot y for this one. That way it's perfectly sized. And now when we go to draw it, which is, or sorry, when we go to initialize the player, which happens in gameplay screen, somewhere down here, player we go, player.init. So here is the actual dimensions of the capsule, which is 1 by 2, and our player sprite is actually a square sprite. So we've actually been stretching him until now because we've been drawing him with the dimensions of our box, which isn't what we want to do. We don't want to actually distort our sprite at all. So when we pass in the, let's say the glm vec2, when we pass in the vec2 for the draw dimensions, we want them to be the same size, and I'm thinking 2.0f is good. And rather than saying 2, what's cool with glm is you can just say 2, and it will use it for both x and y. Now let's see how this looks. There we go. Now the player is much bigger. He fits into the box much better. I do believe the box is still a little bit too tall. As you can see, his head is still a little bit under the top of that collision box. So let's bring it down to 1.8. That'll probably be much better. Now when we run it, there we go. Now it's pretty much perfectly on his head. I think that looks great. Now you'll notice his feet are kind of hanging out of the bottom of this box here, but that's just a result of the sprite we're using. A lot of sprites often have feet in a standing pose that are really close to the bottom, that are kind of standing with their feet together. That's probably what you're more used to. With this, where the feet are apart, we have a little bit of an inaccuracy here because the feet are now poking out of the circle. So if you wanted to, you could do like a half capsule approach where the top is a capsule but the bottom is just a regular bounding box. You could modify this however you want, do whatever feels good. Maybe when he's running you switch to a capsule, but when he's standing still you switch to something else, or you could just switch to a different sprite where when he's standing his feet aren't so far apart. That's really outside of the scope of this tutorial. I've showed you what I wanted to show you. Let's see how it looks without any debug rendering. Let's see. if render debug, where do we set render debug? We just set it in the header file, don't we? So let's set render debug to false and let's run it. And now we have no debug rendering, and as you can see, the player collides pretty well, other than his feet, which of course are kind of hanging off the edge. The bounding box is now much closer to his actual dimensions, so when we run into walls, it looks kind of like he's running into it. Now this will look a lot better with animation, which we are going to be doing in the next tutorial. So thanks for watching, guys, and I will see you next time.